Okay. Hello. Welcome everybody. So this is the week 0 preliminary discussion on operating system fundamentals. This is an NPTEL live session. I am Somnath Hazra, a second year PhD student at IIT Kharagpur. So today we will discuss some preliminary questions. So it will be a short session. From next time it will be a longer session of 1 hour. So let's look at some questions. So this is the first question. Please provide the best possible answer with respect to the definition of an operating system. So an operating system is a system software, an interface between user and computer hardware, a program that runs at all times in a computer, or all of the above. So anybody would like to contribute to the answer? Okay. So now we go towards the answer. So the answer is all of the above. Actually everything is correct, but the best possible answer is all of the above. So that is, an operating system is a system software that is an interface between user and computer hardware, and it is also a program that runs at all times in a computer when it is switched on. So now we go to question 2. So this question is related to the functionalities that are undertaken by the operating system in a computer. So an operating system in a computer is responsible for resource management, process management, security and privacy management, or all of the above. So which among these do you think suits the best to the question? So if anybody would like to contribute.
All of the above?
Yes, that is correct. So an operating system is responsible for all of the above. Not only these, it is also responsible for memory management, disk management, etc. So now we go to the question 3. So this is a simpler question. So which among these is or are an example of operating system? So can you say a Windows NT, Visual Studio, Unix, or all of the above? So which do you think are examples of operating system?
Visual Studio.
Yeah, no, that is not correct. So Windows NT and Unix are examples of operating system. So Visual Studio is an example of application program. So yeah. So now we go to the next question. So this is related to the types of operating system that we can see in most of the theory books. So firstly, there are the single user operating systems. So with regards to single user operating system, it allows only a single user to interact with the system at a time. With regards to batch operating system, it has a batch of operating systems that work parallelly. With regards to network operating system, we can say that it requires internet connectivity for working, and with regards to real-time operating system, it says that it needs deadlines to work with. So which among these 4 statements are correct according to you? So it can be more than one statements also. So can anyone contribute to the answer? Okay, so now we proceed to the answer. So yeah, single user operating systems allow single user to interact with the operating system at a time, and real-time operating systems work with deadlines. But networked operating systems do not require internet connectivity. They require a network to operate. That is, it can be a local area network also. And batch operating systems, they do not work with a batch of operating systems. They work with a batch of tasks that they perform. So now we proceed to the next question. So this is again a very simple question. So this is related to graphical user interface in operating systems. Now it is prevalent. In previous times, it used to be command line interface. So which we saw in which we can see in DOS, MS DOS. So with regards to graphical user interface, which among the following are operating systems? Can you say?
All of the above?
Yeah, all of the above are operating systems. So it's a very simple question. So in command line interface, basically the input medium used to be just the keyboard, not the mouse. But in graphical user interface, you can use both the keyboard and the mouse. And the mouse commands basically used to be like keyboard commands. You have to enter hard code commands to perform a particular task. So now we proceed to the next question. Okay, so this is with respect to interrupts in an operating system. So can you please say which among the following statements are correct? That is, interrupt signals the occurrence of some event to the operating system. Interrupts can arise from hardware or software. Softwares never trigger a system call, and CPU saves the system state before attending to an interrupt. Okay, you need to state that which of the following statements are incorrect among the following. So can anyone contribute? Okay, now we proceed to the answer. So yeah, the softwares actually trigger system call as an interrupt to the operating system. For example, if a word processing software such as MS Word needs to print a document, so it will trigger a system call to the OS saying that it requires some resource, it requires a printing resource, and accordingly a system call will interrupt the operating system, and the process will carry on. Okay, now we proceed to the next question. This is in regards to the main memory of the computer. So the main memory of a computer is the starting point of instruction execution cycle according to von Neumann architecture. It stores the instructions to be executed. It is non-volatile and thus can store the instructions permanently, and it holds the highest position in the storage device hierarchy. That is, according to highest position, I mean to say that it is the fastest to be accessed. So which among the following statements do you think are correct with regard to
Third
the
option.
memory? Sorry?
Sir, third option, sir.
Okay, so no, the third and fourth options are incorrect actually. So the first two options are correct, that is, it is the starting point of instruction execution cycle and it stores instructions to be executed, but it is volatile actually. That is, when the computer is switched off, it cannot store the instructions, and it does not occupy the highest position in the storage device hierarchy. The registers actually occupy the highest positions in the storage device hierarchy, that is, they are the fastest. So now we come to a question related to storage device hierarchy. So related to that, can you please say that if it is designed based on the cost per bit and access time, it has registers holding the highest spot, that is the fastest but also the costliest. It signifies magnetic tapes as the devices with the maximum storage capacity, or it is an indication of the sequence of instructions that travel for execution. Can you say that which of the following statements are correct with regards to storage device hierarchy? So I have already answered one, that is the option 2 is correct. So among the rest, can you please say?
All of them are correct.
No, actually, magnetic tapes do not always contain the maximum storage capacity. So it can be magnetic discs also. So although they are placed at the bottom of the hierarchy, but that does not signify that it will get the maximum storage capacity, because that hierarchy is not designed based on that. It is designed based on the cost per bit access time, cost per bit and the access time that the storage device requires. So now the next question. So this is in regards to multiprocessor systems. So the multiprocessor systems have the following advantage over the single processor systems. Can you state which among the options are correct? That is, it has economy of scale, it has better throughput, and it is better reliable. Can you state which one is correct, or all of the above?
All of the above.
Yes, that is correct. That is, it can share many resources, so it is an economy of so it provides an economy of scale. Also, the throughput of course is more since it has multiple processors, but it is not exactly multiplicative, since it requires a monitor to monitor all the processors so that they work in a sync. But yes, they are reliable also. That is, fault in a single processor does not actually halt the complete system. So yes, all of the above are correct. So this is the last question of the discussion. So this is in regards to multi-core systems. Can you say which is or are correct among these four? That is, they are actually they are exactly the same as multiprocessor systems, or they are architecturally they are similar to single processor systems, or they are capable of parallel processing, or all of the above. Can you state which one is correct?
Second and third options.
Yes, they are correct actually. So yeah, they are not exactly same as multiprocessor systems, because architecturally there are not all the resources are not provided for all the processors. So that is the difference from the multiprocessor systems. Okay, so we come to the end of the discussion. Thank you for your time. Meet you all next week. Thank you. So stop the sharing now.